Hey, what's up, guys? This is Chung. So today, let's take a look at LeetCode problem number 664, string printer. So this one is a very interesting problem. So you're given like a string printer, and the printer following two special requirements. So the first one is that the printer can only print a sequence of the same characters each time. And second, at each turn, right, the printer can print new characters at any of the locations. And then it will cover the original existing characters, which means that it's gonna overwrite the existing characters. So, and here are some examples, right? So we have examples one here, right? Here we have the target is AAABBB. Oh, sorry, and here, and your job is to find the minimum number of turns, the print turns, so that we can get this input, the final answer. And in example one here, right, we have A and BBB. So the final answer is 2. Why is that? Because I mean there are like different multiple approaches for this one. So the explanation this one gives you is to print 3A's altogether and then print B after this, right? And another option is like we do what? We print 6A's in total. And the second time we print 3B's starting from here. Right, so this will also give us the same result here. And then example 2 here, right? So we have like ABA, right? So in this case, I think it's kind of obvious that so we print 3A's first, and then the next turn we just print 1B right in the middle. That's why we got a 2 here. And so there's a hint. Hint says the length of the given string will not exceed 100. So actually, this one is a very pretty strong hint, right? It means that the time complexity for this problem should be O of n cubed. But okay, we can just ignore this one for now. But so let's think about the strategy, right? I mean, at the first glance, this problem I think it's really kind of a little bit confusing and hard to get the point, right? Because there are like different ways, right? We can print any letters, any same sequence of letters at any locations. So how can we approach to the final answer? I mean, I think one of the ways to approach this kind of problem, not especially when you don't have any clues, is that maybe try to find the stupidest, the worst way, or the stupidest, or the most naive way to print this result. So what's the most naive way to print the result? That is, we print the letters one by one, right? So for example, we have an ABA here. So the first time we print A, second time we print B, third time we print A, and this will always guarantee us we can print out the final answer, right? And but this will not give us the minimum turns. So from here, I think the next thing is that, how can we improve this to find a better strategy? Actually, I think the example two here, it's a pretty good example that it's kind of obvious to us that, is if we have multiple numbers, right? Uh, Multiple like letters have the same letters. I think the approach is that we may want to print those letters first. So what I mean is that, so we have let's say we have a x x x, right? Then so let's say we have another a here, right? Mm, yeah, so it doesn't really matter like what's the others letters are at the moment. So let's take a look at these two letters here. So we have two a's. So what's a better strategy other than print the letters one by one? is what is we basically will try to print A, right? We'll try to print all A's here because in this case we can cover, right? We can cover the basically we can get two A's in one turn, and then the remaining parts is that we just give it to the and then the next turn we'll try to print the remaining parts, whatever whatever it's left, right? What's left, whatever is left right in the middle, and then we have another parts here. That's the remaining parts we also need to print. And at this moment, I think it's we can define like a DP here, right? So the DPIJ means from I to J, the minimum turns, right? Print 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 from I to J, the minimum turns. What's the minimum turn to print the letters from I to J? So for the state transition function, right? So this one is obviously the most important one. So which means that we have a dpij equals to what? Equals to the dpi. Let's say that here we have a k, right? ij k minus one plus dp k plus one to j. The second part is kind of obvious, right? Because we need to print them anyway. That's the k plus one to j. So for the first part, so y k minus one is also obvious, but why I, right? Why I not I plus one, right? I think some people some of you may have the question is that okay, since maybe our strategy is to print uh this AAA first, right? And then we'll try to print the 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 middle one. So why not have like a DP of I plus one, K minus one, and then plus one, right? So that's gonna be maybe that's another valid state transition function, but that's not 100% true. So why is that? Because let's say we have like, okay, yeah, here's a good example. We have a AAA. Let's say from A to A, they're all A's. So let's say those four axes, they're all A's. So we have I and J here, right? So if we're using like this kind of DP I plus one, right? I plus one K minus one, and then we do a plus one in the end. So we have this one. Basically, we're saying, okay, we're assuming we're going to print two A's, two A. That's gonna take one turn, and then we're gonna try to print the middle ones, right? But if we keep doing this A here, so what we will have instead of one here, we'll have like maybe three. Because actually for all A's, what's gonna be the answer for that? It's gonna be one because all we need is to print it once because we can cover all this kind of scenarios. Oh, sorry, all the letters. But if our state transition function is something like dpi plus one, k minus one plus one, basically that's not always the case. It makes sense, if the number is something, if the letters in the middle is something like B, C, D, D, A. I'm sorry, B, B, D, C, right? So if that's the case, so this I plus one, k minus one plus one seems fine, right? But that's only covers some cases, but for not all cases. That's why we cannot define the state transition function like this because we have like this kind of AAAA case. Okay, so that's why the way we're defining the state transition function is that mm, it's like this. So we're not considering that plus one because we don't know if that will be additional turn for sure or not. So what we can say is that, since this A and A, they are the same, right? So to print from I to J is equivalent to print from from I to K is equivalent to print from I to K minus 1. Because, it's kind of obvious, right? Because we have another A uh, next to K minus 1. If we take, like, let's say three times to print from I to K minus 1, so we should we should also print another A until K, because this A and A, they're the same. So we should, like, cover this A, I mean, as well. That's what this like the DPI K minus 1 means. Since we're defining this state transition function like in this way, and we can cover this case, right? As you guys can see here, right? So to print this A to A is equivalent, it's the same as to print this A to this A. And then this one is the same as from to this A to this A, and then to here, to here, to to here, right? And in the end, we'll only have one. That's why this state transition function works. And yeah, I think that's basically going to be our state transition function. And this part is kind of obvious. The only thing we need to be careful is that, the k minus 1 might be greater than j, right? So let's say if the a is in the end, right? So if here, if we have a here, so then there's nothing next to a here, so this part should be 0, right? So we can just simply do a check. Yeah, and that's basically the state transition function. And like I said, that's only the scenario when we have like a matching letters with the same I here. Then we can use this state transition function, right? What if there's no A's at all? What if there's nothing to be matched with A? How to handle that case, right? Because here we're saying that, okay, we're we're saying we have a K somewhere, uh, K, like after I here. After I here, there's a K, so that we can split this DP. But what if there's no another A at all? Then what's gonna be that? How about that one? So for that one, we're gonna be a 1 plus, or gonna be a DP of I plus 1 to K, and then we do a plus 1. Sorry, I plus 1 to J. So this one means that, if there's no matching letters for the i's letters, then we have no other options but to print these letters by itself. So by printing the letters by itself, we have one, right? And the remaining, since we're only printing this one letters, the remaining string is from I plus 1 to J. Yeah, so that's basically the final state transition function here. And yeah, we can start coding here. Mm, cool. So we have an n, right, equals the length of s here. And then we're gonna define like dp, right? So dp, since we're getting the minimum, I'm gonna initialize everything to this to the system maximum for it's gonna be a two-dimensional array here, right? And oh, I think one thing I haven't mentioned that is that there are like some base cases. So the base case is like if there's only one letters, right? It doesn't really matter what letter it is, so it's gonna be always one turn to print that letter. That's why we can initialize some basic cases here. Basically from from 0 to n here, we can always initialize the dpi to I to the value 1. So it means that, to print each letter separately, we always need one turn. Okay, so basically that's we have already handled all the length equals to one case. Now we can basically start looping through from length 2. Okay. Oh, by the way, so the this looping the outer loop is a length is a common technique if we want to loop through the all the combinations for like the range I to j. Basically, from the outer loop is the length for the string I and j, and then the inner loop we can simply loop through I from n minus l plus 1. That's going to be all the possible uh, locations for I with the length l, and then we can easily calculate j going to be I plus l minus 1. Okay, and like I said, so the first case is the first one is to print ith letter separately. So if that's the case, we're gonna have like to for j equals to l plus sorry dp I plus 1 j, and then we plus 1. Like I said, we can we can check if there's anything matching the ith letters, and then we can have like if else. But another way of doing this is like we're always assuming we can print this letter separately that can cover that case. So later on we can just use this one to compare to get as a base case to get the minimum result. So now the next thing is that for k in range of I plus 1. Sorry, that's my Siri. And so here, the reason I do I plus 1 is because let's say we have a here, right? So we have another one. Since we have already considered to print the isolator separately case, the next one, like I said, we need to find another matching a's after a, right? Other than the a here. That's why we have to start from this is I, right? That's why we need to start from I plus 1, and we stop from to the j. So if the si is equal to the sk, then we just do the state transition function. dpij is going to be a minimum of dpij dpik minus 1, right? Plus the dpk plus 1j, right? But like I said, since the k plus 1 could be greater than j here, so we can simply have like a if else check here. So which means that uh, we do this if j is greater than k, right? Else 0. Yep. And so here in the end, we simply return the dp 0 to n minus 1. That's our meaning for the entire string. What's the minimum uh, turns we need to print that? Mm, yep. So let's try to run the code. So this one accepted. Let's submit. Uh, oh, yeah, there's a special case, which means that um, if not as, right? So we simply return 0. Yep. Mm, yep. So it passed. And yeah, I mean for the time complexity, I think we have already talked about that. It's gonna be a O of n cube, okay? Because we have a 3 nested for loop here. Mm, yeah, I think that's pretty much for this problem. I mean, I think to be honest, this one is it's going to be a little bit tricky to come up with the state transition functions, right? And also, you have to be insightful enough to notice that we have a different scenarios, and also how can you do this state transition function so that you can handle this like all A cases. Yeah, there are like a bit several corner cases you need to cover. And yeah, just to recap, right? So we start we start with trying to build these strings like naively by printing the letters one by one, and then along the way we figure out, if we have two letters that are the same, so we should print all them together. That's how we get this dpij equals to dpik minus one case. And then the second part is all kind of obvious. And another common technique is for this kind of state problem is that, for dpi and j, we're always gonna basically try all the possible split points, right? On this in this range, and then we try to split them into two parts, and then among all those possible splits, we'll either get a minimum or a maximum. So in the end, we'll just need to return the DP from start to the end. Mm, yeah, cool. I think that's pretty much I want to talk about for this problem. And yeah, thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.